Welcome to Vending University, the ultimate guide to becoming a vending operator. In this specialized course, 3D printing for vending machine components, we'll explore how cutting-edge technology is revolutionizing the vending industry. Whether you're new to vending or an experienced operator looking to reduce costs, streamline repairs, or customize your machines, 3D printing opens new doors for innovation, flexibility, and profitability. In today's fast-paced world, vending operators must adapt to meet the evolving needs of customers and the equipment they rely on. Traditional repair parts can be expensive, difficult to source, or even discontinued. Downtime due to broken components means lost revenue and frustrated users. But now, with 3D printing, you can manufacture replacement parts in-house, create customized machine enhancements, and reduce your dependency on suppliers. It's not just cost-effective, it's empowering. This course is designed to help you understand the fundamentals of 3D printing, including how to choose the right materials and printers for vending applications, how to design or modify components using CAD software, and how to test and implement your creations safely. You'll learn which parts are best suited for 3D printing, such as coin return buttons, internal brackets, levers, and display panel covers, and which are better left to traditional manufacturing. We'll also cover real-world case studies of vending operators who've successfully used 3D printing to cut costs, avoid delays, and even launch their own side businesses by supplying parts to others. From there, we'll walk through the full 3D printing workflow, from design and prototyping to final installation and machine testing. Whether you want to print a simple replacement latch or a fully customized fascia, this course will give you the tools and confidence to take control of your vending repairs like never before. By the end of this module, you'll not only understand how 3D printing works, you'll be able to apply it directly to your vending business. Let's get started. Module 1: Introduction to 3D Printing in the Vending Industry. In this module, we'll explore the revolutionary impact of 3D printing on the vending industry. 3D printing, or additive manufacturing, allows you to create precise, custom parts by adding material layer by layer, offering new solutions for vending machine operators. This technology enables you to print replacement components, customize designs, and significantly reduce operational downtime. Traditionally, sourcing replacement parts for vending machines involved dealing with suppliers, waiting for delivery, and paying high prices for even simple components. With 3D printing, you can produce parts in-house, on demand, and at a fraction of the cost. Whether it's for a broken coil, faulty push button, or a missing bracket, 3D printing provides a fast, cost-effective solution to these common problems. In addition to repairs, 3D printing offers tremendous opportunities for customization. You can design unique parts that align with your brand, improve machine performance, or even tailor components for specific product sizes. Operators who embrace this technology often find that it enhances not only their machine's functionality, but also their ability to respond to customer demands more efficiently. Furthermore, the efficiency of 3D printing reduces your reliance on external suppliers, saving you both time and money. The process is especially beneficial for operators managing multiple machines, as it allows you to handle repairs quickly and without waiting for parts to arrive. Plus, 3D printing can help ensure that your machines remain operational, even when traditional parts are out of stock or no longer available. Throughout this module, you will gain a foundational understanding of how 3D printing works, why it's a valuable tool for vending operators, and how it can revolutionize your vending business. By the end, you'll be able to see the potential of 3D printing and how it can save time, money, and effort in the long run. Module 2: Essential 3D printing hardware for vending machine parts. In this module, we'll dive into the essential hardware needed for 3D printing vending machine components. To get started with 3D printing, it's crucial to understand the equipment you'll need. The right hardware will enable you to print accurate, durable parts tailored to your vending machines. The first key piece of equipment is the 3D printer itself. There are several types of 3D printers available, but for vending machine parts, you'll want a printer that offers high precision and reliability. Fused Deposition Modeling, FDM. Printers are among the most commonly used for producing functional vending machine components. They work by extruding plastic filament, layer by layer, to create the desired part. FDM printers are cost-effective and well-suited for a variety of materials. Next, you'll need to choose the right 3D printing materials. The material you select will greatly affect the durability and functionality of the part you're printing. Commonly used materials include PLA, polylactic acid, ABS, acrylonitrile butadiene styrene, and PETG, polyethylene terephthalate glycol. PLA is ideal for prototypes, but it may not be strong enough for long-term use in high-stress components. ABS and PETG offer more durability, making them better choices for parts like levers, brackets, and other critical components in vending machines. In addition to the printer and materials, you'll need CAD, computer-aided design, software to design your components. Software like Tinkercad or Fusion 360 allows you to create or modify 3D models that can then be printed. These designs need to be highly accurate, as even small design flaws can cause parts to malfunction. Some software options also include built-in simulations to check the strength and fit of parts before printing them. For those looking to improve efficiency, 3D scanners can be an invaluable tool. These devices allow you to scan an existing part, creating a digital model that can be modified and printed as a replacement. This is particularly useful when replicating complex parts that are no longer available. By understanding the essential 3D printing hardware, you'll be equipped to create quality vending machine parts that meet your needs. Investing in the right equipment will not only save you time and money, but will also help you maintain fully functional machines ready to serve your customers. Module 3. Choosing the right materials for vending component durability. In this module, we'll focus on one of the most critical aspects of 3D printing for vending machines: selecting the right materials for your components. The material you choose directly impacts the durability, functionality, and longevity of the parts you print. Understanding the properties of various 3D printing materials is essential to ensure your vending machine components can withstand daily wear and tear. The most common 3D printing materials are PLA, polylactic acid, ABS, acrylonitrile butadiene styrene, and PETG, polyethylene terephthalate glycol, each of which has its own set of strengths and weaknesses. PLA is the most commonly used material, especially for prototypes and non-functional parts. While it is easy to print and environmentally friendly, it's relatively brittle and may not be the best choice for parts exposed to high stress or heat. For parts that need greater strength, ABS is often the preferred material. ABS is tougher, more flexible, and has higher heat resistance than PLA, making it suitable for components like levers, hinges, and coin mechanisms that experience frequent movement. However, ABS tends to warp during printing and requires a heated bed, which can make the printing process more complex. PETG is another popular choice due to its durability and flexibility. It combines the strength of ABS with the ease of printing found in PLA, offering a great balance between performance and ease of use. PETG is resistant to impact, chemicals, and moisture, making it ideal for parts exposed to outdoor elements or frequent handling, such as buttons and vending trays. Another material to consider is nylon, which is highly durable, wear-resistant, and flexible. While it is more challenging to print, It's a fantastic choice for components that require high tensile strength, such as gears and internal mechanical parts. However, nylon tends to absorb moisture, so proper storage is essential. When selecting a material, you must also consider factors like environmental conditions and the weight tolerance of the part. For example, if a part will be exposed to sunlight or extreme temperatures, you may need a material that can resist UV degradation or heat. Similarly, parts that carry heavy loads or bear weight should be printed using materials with high tensile strength, such as ABS or PETG. In conclusion, choosing the right material is essential for ensuring the durability and functionality of your 3D printed vending components. By carefully selecting the material based on your part's requirements, you can create strong, long-lasting components that will help your vending machines run smoothly and efficiently. Module 4. Designing vending machine components with CAD software. In this module, we'll explore the role of computer-aided design, CAD software, in designing custom components for vending machines. CAD software allows you to create precise 3D models of vending parts that can be directly sent to your 3D printer. With the right design, you can create parts that fit perfectly, perform as needed, and are optimized for the 3D printing process. The first step in designing vending components is choosing the right CAD software. Popular options for 3D printing include Tinkercad, Fusion 360, and SolidWorks. These tools enable you to create models from scratch or modify existing designs. For beginners, Tinkercad is an easy-to-use, browser-based program, ideal for simple parts like buttons and brackets. Fusion 360 offers more advanced features for more complex components, such as internal gears and motors. If you need professional-grade tools, SolidWorks offers a comprehensive set of design features tailored for highly technical parts. Once you've chosen your software, the next step is creating the design. The key to designing functional vending machine parts is precision. Every measurement, from the width of a slot to the size of a fastener, needs to be accurate. Most CAD software allows you to set specific measurements and work in 3D space, ensuring that the parts will fit together properly and work effectively in the real world. When designing vending components, it's important to think about the mechanical properties of the part, such as how it will interact with other components or withstand stress. For example, if you're designing a coin mechanism, you need to ensure the slots align perfectly with the coin insert and that the part can handle repeated use without wearing down. You'll also want to consider aspects like tolerances, the acceptable margins for errors in size, and clearances, the gaps between moving parts. Another important consideration is printability. Not all designs are ideal for 3D printing. Complex overhangs, intricate details, or unsupported structures can make parts difficult or impossible to print effectively. Most CAD software includes built-in tools for checking the design for printability, allowing you to adjust the model before printing. In conclusion, mastering CAD software is essential for designing high-quality vending machine components. With the right tools and skills, you can create custom parts that improve your machine's functionality, save on repair costs, and ensure your vending operations run smoothly. Module 5. Printing high-stress parts, gears, hinges, and levers. In this module, we will focus on printing high-stress parts for vending machines, such as gears, hinges, and levers. These components are critical to the machine's functionality and are subjected to frequent use, which makes it essential to print them with materials and techniques that can withstand significant wear and tear. Properly designing and printing these parts ensures that your vending machines operate smoothly and efficiently over time. Gears, for example, are integral to many vending machine mechanisms, from coin sorting to product dispensing. Gears must be designed with precision to ensure smooth meshing and prevent unnecessary friction. For these parts, durability is key. ABS and PETG are excellent choices for gear printing due to their strength and flexibility. Both materials resist impact well, and their durability allows the gears to endure the constant motion within the machine. When printing hinges, it's essential to ensure the material used has the right balance of flexibility and strength. Hinges are often exposed to bending forces as the door of the machine opens and closes. For this, PETG is a good material choice because of its ability to bend without breaking. However, in some cases, nylon might be the better option due to its superior wear resistance and strength, especially for larger or heavier doors. Levers, often found in dispensing mechanisms or coin release systems, also face a great deal of stress. These parts must be designed to handle repeated pressure and movement without cracking or deforming. Like gears and hinges, levers benefit from ABS or PETG because these materials can endure repetitive use. When designing levers, be mindful of the force distribution across the part to prevent weak points that could lead to premature failure. In all these cases, printability and part accuracy are crucial. High-stress parts must be printed with precision to ensure they fit properly and perform their intended functions without failure. Additionally, layer adhesion is key for strength. The layer bonding during the printing process determines how well the part holds up under stress, so adjusting print settings, such as print speed and temperature, can significantly improve part durability. In conclusion, printing high-stress parts like gears, hinges, and levers requires careful material selection, design, and printing techniques. By choosing the right materials and optimizing your designs for 3D printing, you can create components that enhance the longevity and functionality of your vending machines, reducing downtime and maintenance costs. Module 6. Replacing broken vending components with custom prints. In this module, we will explore how 3D printing can be used to replace broken vending machine components with custom prints. One of the key benefits of 3D printing is the ability to quickly and efficiently create replacement parts for your vending machines, minimizing downtime and avoiding the high costs associated with ordering pre-manufactured parts. Whether it's a malfunctioning coin mechanism or a broken product dispensing tray, custom prints allow you to create components tailored to your machine's exact needs. When a vending component breaks, the first step is to assess the part's design and functionality. In many cases, the damaged part can be replicated using 3D modeling software, which allows you to create an exact digital replica of the original part. With this digital design, you can modify the part if necessary, adjusting its features to improve functionality or durability. For example, if the original part was prone to cracking, you could reinforce the design by adding thicker walls or more support in high-stress areas. Once you have the design ready, the next step is printing the part. Depending on the complexity of the component and its material requirements, you will choose the appropriate 3D printing method and material. For most vending components, ABS or PETG are ideal choices due to their durability and resistance to wear. If the part will experience significant stress, such as a coin mechanism or door hinge, using nylon may be more appropriate due to its high tensile strength. After printing, the custom component can be tested in the machine. It's important to verify that the part fits properly and functions as expected. Often, small adjustments are needed, and this is one of the advantages of 3D printing. It's much easier to make quick modifications compared to traditional manufacturing methods. This ability to test and iterate quickly can lead to improved machine performance and reduce the likelihood of future breakdowns. In conclusion, replacing broken vending components with custom 3D printed parts offers numerous advantages. It provides a cost-effective and efficient solution to repair and maintenance needs, ensures you can replace even hard-to-find parts, and allows you to improve the functionality of your machines. By incorporating 3D printing into your vending operations, you can keep your machines running smoothly and reduce long-term costs. Module 7. Prototyping and testing. Fit for functional vending parts. In this module, we will focus on the crucial process of prototyping and testing the fit of functional vending machine parts. Prototyping allows you to create and evaluate a physical version of a component before committing to mass production, ensuring that the part will perform as expected in a real-world environment. This iterative process is essential to avoid costly mistakes and improve the design and functionality of your vending machine components. The first step in prototyping is creating a digital model of the part using CAD software. Once the design is complete, you can print the prototype using 3D printing. This prototype serves as an early version of the part that can be physically tested, helping you identify any design flaws or issues with functionality. For example, you might discover that a part doesn't fit as expected within the machine, or it doesn't interact properly with other components. Prototyping allows you to identify these problems early before moving to full production. One of the key advantages of 3D printing is its ability to create prototypes quickly and at a lower cost than traditional manufacturing methods. This makes it possible to test multiple iterations of a part in a short amount of time. During the testing phase, you may find that adjustments are necessary, such as changing the shape or size of the component or modifying the material for better performance. Since the printing process is relatively fast, it's easy to make changes and reprint the part until the ideal fit is achieved. After printing and testing the prototype, it's essential to evaluate the functionality of the part in the context of the full vending machine. This includes testing how the part interacts with other components and ensuring that it can withstand the stress and wear it will experience in daily use. For example, if you're prototyping a coin mechanism, you'll want to test whether coins are inserted and ejected smoothly and if the mechanism works reliably over repeated cycles. In conclusion, prototyping and testing the fit of functional vending machine parts are vital steps in the design process. By creating and testing prototypes, you can ensure that your parts will function correctly and fit seamlessly within your machines, ultimately improving the performance and longevity of your vending operations. Module 8. Post-processing techniques for strength and aesthetic finish. In this module, we will explore the post-processing techniques that enhance the strength and aesthetic finish of 3D printed vending machine components. While 3D printing can create highly functional parts, the post-processing phase is critical for ensuring that the final product meets both durability standards and visual quality. These techniques can significantly improve the overall performance and appearance of the parts, making them more suitable for vending machine environments. One of the most important post-processing steps is smoothing the surface. 3D printed parts often have visible layer lines due to the additive nature of the printing process. To improve the aesthetic appearance, these lines can be smoothed using techniques such as sanding or chemical smoothing. Sanding is done by hand or with a machine, gradually removing layer lines and creating a smooth surface. Chemical smoothing, typically using substances like acetone for ABS or specialized solutions for PLA, can help dissolve the outer layer of the print, resulting in a glossy and smooth finish. Another vital post-processing technique is reinforcing the part for added strength. While 3D printed parts are generally durable, certain components, such as those exposed to high stress or frequent movement, can benefit from additional reinforcement. Techniques such as epoxy coating or carbon fiber reinforcement can add significant strength to parts. Epoxy coating, in particular, can help improve the resistance of parts to wear and tear. while carbon fiber reinforcement provides a lightweight yet strong solution for high-performance parts like gears and levers. For components that require specific color finishes or branding, painting and decals can be applied. Painting helps to not only enhance the visual appeal of a component, but also provides an extra layer of protection against environmental factors like moisture or UV rays. If branding is required, custom decals can be used to add logos or text to the parts, making the vending machine components look professional and cohesive. Finally, testing the strength of the post-processed parts is essential. Once the part has undergone these finishing processes, it should be tested for performance and durability. Conducting stress tests and wear simulations can ensure that the enhancements have successfully improved the component's strength and longevity in real-world applications. In conclusion, post-processing techniques are essential for both improving the functionality and aesthetics of 3D printed vending machine parts. By applying the right methods, you can ensure your parts not only meet the required strength standards, but also have a professional, polished appearance. Post-processing helps extend the lifespan of your vending machine components, contributing to the long-term success of your operations. Module 9. Compliance, Safety, and Maintenance for 3D Printed Components. In this module, we will address the important considerations of compliance, safety, and maintenance when using 3D printed components in vending machines. While 3D printing offers numerous advantages, including customizability and rapid production, it is essential to ensure that your printed parts adhere to safety standards, regulations, and are properly maintained to guarantee optimal performance and durability over time. Compliance is a critical factor when using 3D printed parts for vending machines. In many regions, vending machines must comply with specific industry regulations to ensure they are safe for public use. This includes meeting electrical safety standards, hygiene requirements, and mechanical safety guidelines. For example, printed components that come into direct contact with food or beverages need to be made from FDA-approved materials to prevent contamination. Furthermore, certain components like coin mechanisms or dispensing systems must meet stringent safety standards to avoid malfunctions that could pose a risk to users. Before incorporating 3D printed parts, it is essential to research and ensure compliance with the relevant laws and certifications that govern vending machine components. Safety is another crucial concern. While 3D printing can produce strong and functional parts, it's important to ensure that these parts are safe for their intended use. For example, parts like gears, hinges, or electrical connectors should be able to handle the stresses of daily operations without failure. Using materials that are durable and capable of withstanding repeated mechanical stresses is vital. Additionally, some printed parts may have sharp edges or points that could be hazardous. Post-processing, such as sanding or smoothing, can help reduce these risks. Regularly inspecting and testing the parts for signs of wear or degradation is also important for maintaining overall safety. Maintenance of 3D printed components is essential to keep your vending machines running smoothly. While 3D printed parts are often designed for durability, they are still susceptible to wear over time, especially in high-stress areas. Regular maintenance should include checking for signs of cracking, warping, or other forms of damage that could compromise the part's functionality. Implementing a scheduled maintenance routine, including cleaning and lubrication where necessary, can prolong the life of your parts. It's also crucial to have a replacement plan in place, as some 3D printed components may eventually wear out and need to be replaced. In conclusion, ensuring compliance with regulations, prioritizing safety, and maintaining 3D printed parts are essential for the successful integration of custom components into your vending machines. By following safety standards and implementing regular maintenance practices, you can ensure that your vending machines remain reliable, safe, and compliant for long-term use. Module 10. Scaling your vending operation with on-demand 3D printing. In this module, we will explore how on-demand 3D printing can help scale your vending operation efficiently and cost-effectively. As the demand for vending machines and their components increases, traditional manufacturing methods can become expensive and time-consuming. With 3D printing, however, you can create custom parts quickly and at a fraction of the cost, which allows for more flexibility and growth in your business. Scaling your vending operation with on-demand 3D printing involves leveraging the technology to streamline production, reduce costs, and maintain a competitive edge. One of the key benefits of on-demand 3D printing is the ability to produce components as needed, without the need for large-scale production runs or expensive inventory management. This just-in-time production model ensures that you can meet the demands of your customers without overstocking or being burdened by excess parts. For instance, if you need a specific part for a vending machine repair or customization, you can simply design, print, and install it as required, without waiting for traditional manufacturers to produce and ship the part. This on-demand capability significantly reduces lead times, making your operation more responsive and adaptable. Additionally, 3D printing offers the ability to rapidly prototype and test new components, which is particularly valuable when expanding or modifying your vending machine offerings. For example, if you want to offer a new type of product in your vending machine, 3D printing allows you to quickly design and produce the necessary custom parts to accommodate the new items. This flexibility is key to staying ahead of the competition and meeting the evolving needs of your customers. On-demand 3D printing also supports scalability by reducing reliance on third-party manufacturers. By bringing the production of parts in-house, you gain full control over the quality and speed of your supply chain. This not only lowers costs, but also ensures that parts are tailored to your specific requirements, minimizing the risk of parts that don't fit or function properly in your vending machines. In conclusion, scaling your vending operation with on-demand 3D printing allows for faster production, cost savings, and greater flexibility. Whether you're replacing broken parts, customizing machines for new products, or rapidly prototyping new ideas, 3D printing gives you the tools to expand your business efficiently and effectively. By embracing this technology, you can improve your vending machine operations and stay competitive in an ever-evolving market. Conclusion. As we reach the conclusion of this course on 3D printing for vending machine components, it's clear that this technology holds transformative potential for the vending industry. From rapid prototyping to on-demand production, 3D printing offers a range of benefits that can significantly enhance your vending machine operations. By incorporating 3D printing into your workflow, you gain the ability to create custom parts quickly, reduce costs, and improve the overall efficiency of your business. The key takeaway from this course is that 3D printing is not just a tool for prototyping, but a powerful resource for long-term innovation and problem-solving in vending machine maintenance and design. Whether it's printing high-stress components like gears and levers, designing new parts using CAD software, or improving the durability and aesthetics of your prints with post-processing, 3D printing can be applied at every stage of your vending machine management. Moreover, it allows for greater flexibility when scaling your operations, as you can produce parts on demand without the constraints of traditional manufacturing methods. By understanding the specific hardware and materials needed for printing vending components, as well as mastering design and testing techniques, you can ensure that your printed parts are both functional and reliable. Additionally, the ability to replace broken parts and customize vending machines on the fly ensures that your business remains agile and responsive to customer needs. Importantly, by adhering to safety, compliance, and maintenance guidelines, you ensure that your 3D printed components meet industry standards and continue to perform optimally over time. The ability to integrate 3D printing into your vending operations offers a pathway to both innovation and efficiency. Whether you are a new operator or looking to optimize an existing fleet of vending machines, mastering 3D printing for components opens up new opportunities to reduce downtime, enhance service, and create more customized experiences for your customers. As you continue to explore this technology, you'll unlock even more ways to improve your business and stay ahead of the competition. In conclusion, the future of vending machines is closely linked to advancements in 3D printing. By implementing these skills, you can position your business at the forefront of this technological revolution.